Welcome to another nostalgic math ramble. Today we are looking at NSC. NSC, all these papers are NSC. So specifically the DBE, the department's paper, from May 2023, paper 1. Right, question 1.3. Determine without the use of a calculator, in bold, the value of 1 over root 1 plus root 2 plus 1 over root 2 plus root 3 plus 1 over root 3 plus root 4 plus and so on plus 1 over root 99 plus root 100. Okay, so I'm just going to say right up front that I have no idea what to do with myself. So obviously, like, there's a lot of surds going on here, and we've got surds in the denominators. So that the thing that it just sets off in my brains straight away is rationalizing the denominators. So that's just because that's a force of habit. I was always taught you must rationalize your denominators whenever you can, whenever you have the opportunity. But also for a practical reason, I think if by rationalizing the denominators, we're going to end up with whole numbers in the denominators, or at least integers. So that would at least make them easier to work with. If I do want to end up actually adding them up. So yeah, I'm just going to start there. I'm just going to start by rationalizing. I don't know how I feel about red. Maybe let's go green. So 1 over root, what is happening? Right, so that we rationalize by multiplying with the conjugate, right, which is just the same expression except the plus becomes a minus. So what we're doing there is we're going to create a difference of two squares. Anyway, so what you do at the bottom, you do at the top, so that in effect you're just timesing by 1. So you're not actually changing this number, you're just timesing it by 1. So right, so this is going to be root 1 times root 1, which is just 1, and then root 1 times minus root 2 plus root 1 times root 2. So those are going to cancel out, right? Because we're going to have negative root 1 root 2 plus root 1 root 2, right? So the plus is from here, the minus is from here. Okay, so those two will cancel out. So what we're left with is root 2 times negative root 2, which is going to give us negative 2. And at the top, we're going to have root 1 minus root 2. So we've got root 1 minus root 2, and at the bottom, we've got a negative 1. I don't know if I want to do anything with that yet. So I'm just going to leave it as is. No, I'm not. I can't. But I definitely do not want to get rid of the denominator, because I have a feeling that when I rationalize for the rest of them, we're going to end up with some non-1 number at the bottom. So we're going to end up having to put this into a fraction anyway, so that it looks like the other terms, if that makes sense. Okay, so what I will do is I will say, okay, that negative flips our difference around, right? So we're just left with a positive 1 at the bottom there. Okay, right. Okay, if that is weird, I just want to show why that is true. Okay, if you have something like that, a minus b over negative c, that is the same as if you factor out a negative 1 over here. So that would be a negative a plus b, right? And this would be a negative 1 times c. So these would cancel out, and you would just be left with minus a plus b, which is the same as b minus a, and at the bottom you'd be left with positive c. So that's what we've done over there. The negative does a switcheroo of these two, and then you're just left with the positive one down there. In very unnice, unmaths words. Okay, right. Next term, let's look at the next term. So the next term, and it's written a different color. So that'll be 1 over this drawer will be the end of me. Right, and we're going to rationalize. So we're going to times by the conjugate at the bottom and also at the top. Right, so the top will just be root 2 minus root 3. And the bottom, if you do FOIL, you'll end up with 2 minus 3. So again, we've got root 2 times root 2, which is just 2. And then root 2 times minus root 3. And then root 2 times positive root 3. So those two will cancel out. And then root 3 times negative root 3 will be minus 3. Okay, righties. So we end up with root 2 minus root 3 divided by minus 1. Oh, so it is possible, it's very likely that we're always going to end up with a minus 1 at the bottom. Interesting. That makes sense, actually. Right, I'm just going to hang on to the positive 1 denominator for now, though. Let's just test with one more term. Okay. Yes. Aha. Yo, Kalki. Okay. Right. So actually, these just end up looking like that. Okay, so now we can get into our pattern heads. Right, we can see what's going on. Oh, screenshots. Leave me alone. That definitely, ooh, it was a sign. Okay, so there's just no winning from all angles. We are not winning. Oh, problems. Yeah, we don't need the question that much at this point. Okay, right, so we can see that this expression that was given to us, obviously you can't write like this in your exam, but you know, I'm just going to abuse my privileges for 2 seconds. So this expression, there's a bit of a square root that got left behind there. Yeah, I hope that is clear. Okay, anyway, so this ends up being root 2 minus root 1, the first term. The next term is root 3 minus root 2. The next term is root 4 minus root 3, right? And so that last term, what will that last term be actually? It's going to end up being, there's 99 terms in this series, right? Because we've got 1, 2, 3. So there's 99 of them. Okay. So, and we know that each term is 1, 2, 2, 3, 3, 4. So if there's 99 terms, then we will have root 99 over here, and then root 100 over there. Also easy enough to figure out if you rationalize this denominator. Right, so what's going to happen is we're going to end up with some cancellations, right? Because we've got a positive root 2 here and a negative 1 over there, and a positive root 3 over here and a negative 1 over there. And then we're going to have a positive root 4 and a negative 1 in here somewhere, right? And over here, we're going to have, there's going to be a term here that is root 99 minus root 98. That's going to be the 98th term, right? Over here. So that one is going to cancel with that one. That one's going to cancel with something before there somewhere, right? So the only terms we're left with are the negative root 1 and the positive root 100. So we're just left with negative root 1 plus root 100, which is minus 1 plus 10, which is 9. Let's see what the memo has to say for itself. The memo says, niege. Fantastico. Okay, so what was the big aha for me over here? I think it was just seeing surds in denominators and instinctively feeling like in order for me to be able to work with these fractions, I at least need to rationalize these denominators, right? Because at least if the denominators are something like 2 and 5 and 7, I know how to find lowest common denominator and we can take it away. We can take it from there. And once I started rationalizing the denominators, it kind of started becoming clear what the pattern was. And then it was a home run from there. So moral of the story from this video for me, is sometimes you don't know where the road is going to go, but just start with basics. And I think the basics in this case is if you see surds in denominators, a good instinct is to try and rationalize those denominators and see what that yields for you. Okay, cool.